Good evening to all. Rahul Jha welcomes you. Today we are going to talk on wind energy. So let's start. What is wind energy? Wind energy is a form of renewable energy that harnesses power of wind to generate electricity. It is a clean and sustainable source of power that has been utilized for centuries with modern wind energy technologies, providing a significant contribution to global electricity generation. The key components of wind energy include wind turbines. Wind turbines are devices that convert the kinetic energy of the wind into mechanical energy. The most common type of wind turbine used for electricity generation is the horizontal axis wind turbine HAWT. It consists of tower and blades mounted on a rotor. The rotor is connected to a generator, and as the wind turns the blade, the generator converts the rotational energy into electrical energy. Wind farms. Wind turbines are often grouped together in wind farms, which consist of multiple turbines strategically placed in areas with consistent strong winds. Wind farms can range in size from a few turbines to hundreds of turbines, depending on the available wind source and energy needs. Wind power plants. Large-scale wind power plants consist of multiple wind farms and are connected to the electrical grid. These power plants generate electricity that can be distributed to homes, business, and industries. How wind energy works? Wind turbine rotation. When the wind blows, it causes the blade of wind turbine to rotate. The kinetic energy from the moving energy air is transferred to the blade. Generator operation. The rotation of the blade drives the rotor connected to the generator. The generator converts the mechanical energy into electrical energy through the principle of electromagnetic induction. Power transmission. The generated electricity is then transmitted through the power lines to homes, businesses, and industries for consumption. Advantages of wind energy. Renewable and sustainable. Wind energy is a renewable source, and as long as sun continues to shine and the earth's atmosphere exists, wind will be generated. It is a sustainable source of electricity. Clean and environmental friendly. Wind energy produces electricity without emitting greenhouse gases or air pollutants. It contributes to reducing reliance on fossil fuels and mitigating climate change. Reduce greenhouse gas emissions. Using wind energy helps reduce the overall carbon footprints by displacing electricity generation from fossil fuels, which releases carbon dioxide and other pollutants into the atmosphere. Cost effective. The cost of wind energy has decreased significantly over the years, making it increasingly competitive with the conventional energy source. Advances in technologies and economies of scale contribute to its cost effectiveness. Job creation. The wind energy sector creates jobs in manufacturing, construction, operation, and maintenance, contributing to economic growth. Land use efficiency. Wind turbines require a relatively small land footprint. The land around the turbines can often be used for other purposes such as agriculture. Challenges of wind energy. Intermittency and variability. Wind energy is variable and intermittent. Depending on wind speed and weather conditions, this can pose challenge for matching supply and demand, requiring additional measures like energy storage or backup power source. Visual and noise impact. Some people find the appearance of wind turbines and the noise that they produce objectionable. This can lead to concerns about their impact on landscape and local community. Bird and cat collisions. Wind turbines can pose threat to birds and bats, especially in areas where significant avian population. Research and proper setting are necessary to minimize the impact. Initial cost. While the operation cost of wind energy are relatively low, the initial capital cost for installing wind turbines and associated infrastructure can be significant. However, these costs have been decreasing over time. Land use conflict. In densely populated areas of a region with competing land uses, there may be conflict over use of land for wind energy projects. Despite these challenges, the continued advancement of wind energy technology, along with research and innovation, is addressing many of these concerns and making wind energy an increasingly viable and important component of the global energy mix. How wind energy can be used to generate electricity? Wind energy is harnessed to generate electricity using wind turbines. These turbines convert the kinetic energy of wind into mechanical energy, which is then transformed into electrical energy through generator. Here is step-by-step explanation of how wind energy can be used to generate electricity. Wind turbines. Design and placement. Wind turbines are designed to capture the kinetic energy of the wind. They consist of a tower and blades mounted on rotor. The tower elevates the rotor to a height where wind is more consistent and stronger. Blade rotation. When the wind blows, it causes the blade of turbines to rotate. The shape and design of blades are optimized to capture as much wind as possible. Mechanical energy conversion. Rotor and generator. The rotation of blade turns the rotor, which is connected to a generator. The generator is a crucial component that converts mechanical energy into electrical energy. Electromagnetic induction. The generator operates on the principle of electromagnetic induction. As the rotor turns, it creates a changing magnetic field. This changing magnetic field induces an electric current in the wire coils of the generator. AC electricity generation. The generated electricity is typically in the form of alternating current. The frequency of alternating current electricity is determined by the rotational speed of rotor and number of poles in the generator. Power transmission. Transformer. The electricity produced by the generator is sent to a transformer. The transformer adjusts the voltage of electricity to a level suitable for transmission. Power lines. The electricity is then transmitted through power lines to a substation. From the substation, it is further distributed to electrical grid. Integration into electrical grid. Grid connection. Wind farms, which consists of multiple wind turbines, are connected to electrical grid. The grid generated by wind turbines becomes part of overall grid supply. Grid balance. Electricity from wind turbines is integrated with other sources of electricity on the grid. Grid operators use sophisticated control systems to balance the supply and demand of electricity, taking into account the intermittent nature of wind energy. Consumer consumption. Electricity consumption. The electricity generated by wind turbines is then distributed to homes, businesses, and industries for consumption. Consumers use this electricity for various purposes such as lighting, heating, cooling, and powering electronic devices. Advantages of wind energy for electricity generation. Renewable and sustainable. Wind energy is a renewable energy as long as the sun continues to shine and Earth's atmosphere exists. Clean and environmentally friendly. Wind energy produces electricity without emitting greenhouse gases or air pollutants, contributing to clean environment. Reduced greenhouse gas emissions. Wind energy helps reduce carbon emissions by displacing electricity generation from fossil fuel. Cost effective. Advances in technology and economic scale have contributed to the decreasing cost of wind energy, making it increasingly competitive with the conventional operation. Job creation. The wind energy sector creates jobs in manufacturing, construction, operation, and maintenance, contributing to economic growth. While wind energy has numerous advantages, it also faces challenges such as intermittency, visual and noise impact, and the need for backup power source. Ongoing research and technology advancement are addressing these challenges and further improving the efficiency and reliability of wind energy system. What are components of wind energy electricity production system and how they work? Wind energy electricity production system consists of several key components that work together to harness the kinetic energy of the wind and convert it into electrical power. Here are the main components and their function in a typical wind energy system. Wind turbine. Rotor blades. Function. Captures kinetic energy from the wind. How it works. Wind causes the rotor blade to spin, converting the wind's kinetic energy into rotational mechanical energy. B. Rotor hub. Function. Connects the rotor blade to the main shaft. How it works. The rotor hub transfers the rotational energy from spinning blades to the main shaft. Nacelle. Function. Encases critical components including generator and gearbox. How it works. Rejects and houses the generator, gearbox and other components from the environmental elements. Main shaft. Function. Transmit rotational energy from rotor to gearbox. How it works. Connects the rotor hub to the gearbox, transmitting the rotational energy. Gearbox. Function. Amplifies the rotational speed of rotor to a level suitable for generator. How it works. Increases the speed of slow spinning rotor to speed suitable for optimal generator efficiency. Generator. Function. Converts mechanical energy into electrical energy. How it works. The generator uses electromagnetic induction to convert rotational energy from gearbox into electrical energy. Tower. Function. Supports the entire wind turbine, elevating the rotor to capture higher wind speeds. How it works. The tower raises the rotor to a height where wind speeds are more consistent and stronger. Control system. Controller. Function. Monitors and controls the operation of wind turbine. How it works. The controller adjusts the pitch of rotor blade and orientation of the nacelle to optimize energy capturing and ensuring safe operation. Power transmission. Transformer. Function. Adjusts the voltage of generated electricity. How it works. The transformer increases the voltage for efficient transmission over power lines. Function. Transmit electricity from wind turbine to electrical grid. How it works. Transmit the electricity generated by the wind turbine to substations and then into electrical grids. Substation. Function. Connects the wind farm to the electrical grid. How it works. This substation receives the electricity from multiple wind turbines in the wind farm, adjusts voltage level and feed the electricity into grid. Electrical grid. Function. Distributes electricity to end users. How it works. The electrical grid receives electricity from various sources including wind farms and distributes it to home, businesses and industries. Foundation. Function. Supports the weight of entire wind turbine. How it works. The foundation anchors the wind turbine securely to the ground, providing stability. Environmental monitoring. Sensors. Functions. Monitor environmental conditions. How it works. Sensors measure wind speed, direction and other meteorological factors to optimize turbine performance and ensure safe operation. Emergency brake system. Function. Stop the rotor in emergency or during maintenance. How it works. Activate the emergency situation to bring the rotor to halt, preventing damage or hazards. Data communication system. Function. Transmit operational data and diagnostics. How it works. Enables communication between individual wind turbine control systems and remote monitoring center for data analysis and troubleshooting. Each component in a wind turbine system plays a critical role in generation of electricity. Advances in technology, research and engineering continue to improve the efficiency, reliability and cost effectiveness of wind energy system. What are advantages and disadvantages? Which are the top companies of the world in the sector? Several companies are prominent in global wind energy sector, involved in manufacturing of wind turbines, development of wind farms, and provision of related services. Keeping in mind that status of companies can change over time due to merger, acquisition, and other industrial dynamics. Here are some of the top companies in the global wind energy sector. Vestas Wind Systems. Vestas is a leading Danish wind turbine manufacturer and one of the largest in the world. The company provides a wide range of wind turbines for onshore and offshore applications. Siemens Gamesa Renewable Energy. Siemens Gamesa, a merger of Siemens Wind Power and Gamesa, is a major player in the wind energy sector. The company offers onshore and offshore wind turbines and provides services across the entire wind power value chain. GR Renewable Energy. General Electric is a diversified conglomerate with a significant presence in the renewable energy sector. GE Renewable Energy manufactures onshore and offshore wind turbines, providing solutions for global wind market. Goldwind. Goldwind is a Chinese wind turbine manufacturer and one of the largest globally. The company produces onshore and offshore wind turbines and involved in wind farm development. ENEL Green Power. ENEL Green Power is a renewable energy division of Italian multinational energy company and ENEL. It is actively involved in development and operation of wind farms worldwide. Enercon. Enercon, based in Germany, is a well-established wind turbine manufacturer. The company is known for direct drive turbine technology and has significant presence in onshore wind projects. Nordex Group. Nordex, a German company, is a major player in the wind energy sector, manufacturing onshore wind turbines. The company focuses on providing sustainable and efficient wind energy solutions. China Longyuan Power Group Corporation. China Longyuan Power is one of the largest wind farm developers and operators in China. It is a subsidiary of China Guodian Corporation and plays a key role in country's wind energy industry. Next Era Energy Source. Next Era Energy Sources, a subsidiary of Next Era Energy, is a leading renewable energy company in the United States. It is involved in wind and solar energy projects and one of the largest wind power producers globally. EDP Renewables. EDP Renewables, a subsidiary of Energias de Portugal, is a global renewable energy company with a focus on wind energy. It develops and operates onshore and offshore wind projects. Please note that ranking and status of these companies may have changed since last update. Additionally, new companies may have emerged and industry dynamics can shift over time. It is advisable to check the latest information. Now, which are the top companies of India in the sector and how much is their production? India has several companies actively involved in wind energy sector. These companies are engaged in manufacturing wind turbines, developing wind projects and providing related services. Keep in mind that specific ranking and production figures can change over time due to industry developments and market dynamics. Here are some important notable companies in Indian wind energy sector. First is Suzlon Energy Limited. Suzlon is one of the largest wind turbine manufacturers in India. The company designs, manufactures and services wind turbines. Suzlon has a significant presence in both domestic and international market. Vestas Wind Technology India Private Limited. Vestas, a global leader in wind energy, also operates in India. The company manufactures and supplies wind turbines for onshore and offshore applications. Vestas is known for its advanced wind turbine technology. Inox Wind Limited. Inox Wind is a prominent player in the Indian wind energy sector. The company is involved in manufacturing wind turbine generators and providing turnkey wind power solution, including project development and operation. Maitra Energy Limited. Maitra Energy is a renewable energy company with a focus on wind power. It develops and operates wind farms across various states in India and has been actively contributing to the country's wind energy capacity. Renew Power Private Limited. Renew Power is one of the largest renewable energy companies in India with a diversified portfolio that includes wind, solar and other renewable energy sources. The company has a significant presence in the wind energy sector. Greenko Group. Greenko is a leading renewable energy company in India with interests in wind, solar and hydroelectric projects. The company has been involved in developing and operating wind projects across the country. Adani Green Energy Limited. Adani Green Energy, part of Adani Group, is a major player in the renewable energy sector. The company has a growing portfolio and wind projects contributing to India's renewable energy goals. CLP India Private Limited. CLP India, a subsidiary of CLP Group, is engaged in developing and operating renewable energy projects, including wind farms. The company has a focus on sustainability and clean energy initiatives. Now, figures of the company can vary and may change with time. Now, wind energy offers several advantages compared to other sources of energy, contributing to its increasing adoption worldwide. Here are some key advantages of wind energy. Renewable and sustainable. Wind energy is a renewable source relying on Earth's natural and wind patterns. As long as sun continues to shine and Earth's atmosphere exists, wind will be generated, making it sustainable source of electricity. Clean and environmentally friendly. Wind energy production does not emit greenhouse gases or air pollutants, contributing to reduction in air pollution and mitigating climate change. It helps decrease dependence on fossil fuels and supports cleaner environment. Reduce greenhouse gas emissions. Wind energy displaces electricity generation from fossil fuel, reducing carbon dioxide and other greenhouse gas emissions. This is crucial in addressing climate change and meeting international climate goals. Low operating cost. Once a wind turbine is installed, the operation and maintenance costs are relatively low compared to conventional power plant. Advances in technologies and economies of scale have contributed to decreasing cost of wind energy. Job creation. The wind energy sector creates jobs in manufacturing, construction operation, maintenance and related industries, contributing to economic growth and employment opportunity. Land use efficiency. Wind turbines have a relatively small land footprint, allowing for multiple land use in surrounding areas. Agricultural activities can often coexist with wind farms. Predictable resource. Wind patterns are generally predictable, allowing for effective planning and integration into energy grid. Wind forecasting technology has improved, helping grid operators manage variability. Technological advancement. Ongoing research and technologies advancement in wind turbine design and efficiency continue to enhance performance of wind energy system, making them more efficient and reliable. As for the target of world production till 2030, global energy targets are often set at the national and international level. Paris Agreement, for example, aims to limit global warming to well below 2 degrees Celsius above pre-industrial level. Nationally determined contributions (NDCs) submitted by countries outline their specific target for reducing greenhouse gas emissions, and many countries include targets for increasing renewable energy capacity, including wind energy. The International Renewable Energy Agency (IRENA) has set a target of doubling the share of renewable energy in the global energy mix by 2030. However, specific production targets for wind energy may vary by country and region. It is essential to consult the latest report, international agreements, and national energy plans for most accurate and up-to-date information.